Good morning students. We will continue the previous class. In that previous class, I was saying you about the refractive index of the prism. That derivation we were deriving. Okay. So at that time, I was explaining you about this graph. Okay. A graph plotted between angle of deviation versus angle of incidence. Okay. Along that y-axis, we have taken angle of deviation. Along that x-axis, we have taken angle of incidence. Look here, according to that nature of graph, for this particular angle of deviation, for this value, it may be any value. For that value, as you come towards the nature of your graph, that your respective value going to touch that curve here. Then from that point you draw one perpendicular towards that x-axis. Here you will be getting one angle of incidence. It means what? If angle of incidence through that prism is this value, then for this value, the angle of deviation you will be getting this much. Getting what I am going to say? If you send that light through that prism with this mentioned value, whatever here it is, with this mentioned value, okay, then it will enter into that prism, it get refract, and finally it get refract from another side surface. There you will be having one angle of deviation. That deviation is being with this value. For this deviation, this much is the angle of incidence. Okay. Further, if you continue that your respective deviation value, then that going to meet that your curve again here. Again means what? From that point again you draw one perpendicular to that x-axis. It going to meet somewhere at one reading. This is a angle of incidence. For this angle of incidence, again there will be this angle of deviation. What it means? If you send the light ray through that prism with this mentioned angle of incidence, with this angle, if you allow that light to fall on that prism, again you will be getting same deviation. Are you getting? If you send with this I1 value, you will get this value, this delta, say it as delta 1, say it as delta 1. Okay? Getting what I meant to say? For I1 you got delta 1, for I2 also you got delta 1. Mean for one particular value of deviation, there are two angle of incidences. Okay? That going to happen everywhere. For this value, if you take this deviation, I mean as a delta 2, for that deviation also, if you come like this, yes, see here, for that also again you will be getting two values, here one and here one more. Getting what I meant to say? Everywhere, for one angle of deviation you will be getting two angle of incidences, but here for this deviation, this is the lowest deviation. Y data telling deviating angle, we coming down, which is lowest in that curve, this value, this deviation value is lowest. That's why I named here M, minimum deviation. Delta M is minimum deviation. Getting what I want to say? Yes. Least deviation, least bending. Okay, that is delta M. For this delta M, for this value, as you come along that you see here, that going to touch here. Yes. From that, if you draw perpendicular to the x-axis, you will be getting only one angle of incidence. Getting what I mean to say? For that minimum deviation, there will be only one angle of incidence. Except that, for every deviation, there are two angle of incidences. Yes. For that minimum angle of deviation, we can treat I is equal to E. What it means I equal to E? I will tell you what it means. See, for that minimum deviation, we can treat I equal to E, and then R1 equal to R2 we can treat. What it means? Just look on that diagram. I will tell you. Just have a look on this diagram. It's very important. Try to get this. See here what I mean to say. Here you sending this PQ light like this and it propagating like this and it finally coming like this. Okay, look here. Just look on P2Q, Q2R and R2. Yes, P2Q, Q2R and R2. Yes. Now you see here, this is angle of incidence and this is angle of emergence. Angle of incidence, angle of emergence. These are R1 and R2. Leave them R1 and R2. What I mean to say, see, for that minimum deviation, we are going to get only one angle of incidence. Okay, so now look here, what it means. If you send light ray like this, P2Q, Q2R, R2S, for this P2Q, for this propagation, you will be getting one delta value. Okay? If you imagine in reverse way, for this angle of incidence, you got some angle of emergence. If you reverse the case, if you imagine like that, light is moving in this way. I mean S to R, R to Q, then Q to P. Then also you will be getting the same deviation. If you send along the path P to Q, Q to R, R to S, you will be getting one deviation. If you send with the same angle here this side, I mean if you go like this, imagination, S to R, R to Q, Q to P, then also you will be getting the same deviation. It means what? That angle of incidence and this angle of emergence are equal for that minimum deviation case. I mean here this is angle of incidence, for that you got delta, some angle of deviation. Getting what I mean? If you imagine light going like this, then also you are getting same delta. It means what? With how much angle light got incident on the prism, here with the same angle light got entered into the prism from this side. That's why we got same deviation. So what we have to treat? Then that I is equal to E. Getting what I mean to say? If you send light along P to Q, Q to R, R to S, you will get one delta. If you imagine you going like this, then also you will get same delta. Then only some changes. It will be like delta will be here, it will come vertically opposite angle. If you go like this, then also you will get the same delta. It means with how much angle light got entered through that prism here, with the same angle that light is entering the prism here. It means what? I and E are equal. that we call as minimum deviation. Okay, if that deviation is minimum, then that refracted light ray through the prism looking like parallel to their base. If it is minimum deviation, then that refracted light ray through the prism, which one? QR, looking parallel to the base of the prism. I mean, this QR is parallel to the BC surface. Have you understood? Yes, this is called as minimum deviation. Have you understood what I mean to say? According to that diagram also, we can conclude like that at minimum deviation, here at minimum deviation, both angle of incidence and angle of emergence are being equal. When I and E are equal, according to that geometry, I mean according to that ray diagram, even we can say that R1 is equal to R2. Getting what I mean to say? R1 is equal to R2. That one only I have written here. That diagram is for which deviation? For minimum deviation. At that minimum deviation, angle of incidence and angle of emergence are equal. When these two are equal, then obviously remaining two angles R1 and R2 are also equal. That I have written here. That I have taken R1 equal to R2, they together I treated as R. Okay? Yes. Now go with the help of these two consideration. Okay? Then see here. Then from equation 3 we can write. What we can write from equation 3? Look on the equation 3. That is telling angle A is equal to sum of angle R1 and R2. Here A is equal to R1 plus R2. Even you can replace R1 by R and R2 by R plus R, 2R. A is equal to 2R. Then R is equal to A by 2. Getting what I mean to say? Here we treat that R as an angle of refraction, that is equal to A by 2. Say it equation number 5. Then from equation 4 we can write. Now look on the equation 4. What it is? You see here. Delta is equal to I plus E minus A. Okay. Here we treated I and E are equal. In place of E, you write again I. Then delta, that minimum deviation. That our consideration is for minimum deviation. That's why subscript M telling it is minimum deviation. Minimum deviation is equal to I plus, this is actual equation. Replace this E by I. 2I minus A, that is delta. Then I is equal to that minimum deviation plus angle A divided by 2. Here I is the angle of incidence. Say it as equation number 6. Equation 5 giving the angle of refraction. Equation 6 giving the angle of incidence. With the help of these two angles, now we can able to find the refractive index of that prism according to Snell's law. What that Snell's law is telling? Snell's law is telling the sign of the ratio of sign of angle of incidence to the sign of angle of refraction is constant, or else it is equal to n2 by n1. Okay, or n1 sin I is equal to n2 sin R. This is Snell's law. With the help of this law only, now we are going to find the refractive index of the prism. See here, n21. Why I written n21? n21 is telling refractive index of medium 2 with respect to medium 1. Medium 2 itself, it is the prism. We treated it as a glass. Getting what I mean? We want refractive index of that prism. I mean of that second medium with respect to first medium. I mean we want N21. That's why I written N21 refractive index of the prism with respect to air material or with respect to that one medium is equal to N2 by N1. That is equal to sin I by sin R. Then go with that refractive index of that prism is equal to sin I. Okay, sin I. Just see here. In place of I written this one from that equation 6. Equation 6 telling I is equal to delta m plus a by 2. Here I have written sin I by sin R is nothing but equal to a by 2. From equation 5 we can write. Okay, this is the formula which is going to give the refractive index of that prism with respect to that medium 1. Have you understood? Here it is very important for your board exam. They will be asking you 5-mark derivation. Derive an expression for refractive index of the prism. Then at that time you have to go with this derivation till reaching this final equation. Okay, then thereafter writing this final equation at below you have to mention what mean N21 and what mean A and what mean delta M. Already I said N21 is the refractive index of the prism with respect to medium 1 and A is the angle of the prism and delta M is the minimum deviation angle for that respective prism, minimum deviation. This is about the refraction through the prism. Okay, refraction through the prism.